P0306 is a cylinder 6 misfire code. On this Ram 1500DT with the 5.7 Hemi, the driver may notice a rough idle, shake under load, loss of power, or a flashing or illuminated MIL. Broadly, this can come from ignition, fuel delivery, air leaks, oil or mechanical issues, and sometimes variable valve operation. Start with the basic system checks, then make sure the misfire monitor actually had a chance to run. Treat the enable conditions as monitor gates: fuel level above 12%, battery voltage above 9 volts, ambient temperature above -23 degrees C -9, 4 degrees F, coolant temperature at engine start above -7 degrees C 19, 4 degrees F, or enable once engine temperature reaches 21 degrees C 69, 8 degrees F, with engine speed between approximately 400 RPM and 6,200 RPM. The PCM sets this code when crankshaft speed variation between cylinders exceeds a calibrated value for the current speed and load. Depending on severity, the MIL can illuminate or flash. During a severe misfire, the PCM can temporarily disable the affected cylinder's fuel injector to protect the catalytic converter, and stop/start can be disabled while the code is active. Turn the ignition on. With the scan tool, read and record all codes and the captured operating data. Then operate the truck under the same captured conditions and watch when the misfire shows up. While it is misfiring, note the downstream O2 sensor behavior and use the misfire monitor to confirm cylinder 6 is the cylinder showing excessive misfires right now. If cylinder 6 is not actively misfiring during the check, treat it as an intermittent condition instead of guessing. If other codes are active or pending in the fuel system, ignition system, air handling system, VVT system, or VVL system, deal with those first because they can steer the misfire diagnosis. Before getting deep into cylinder-specific testing, look over the engine for the common things that can fake or cause a misfire. Check belt condition, accessory pulley alignment or binding, sensor mounting for crank, cam, and MAP inputs, connector and terminal condition at the key engine components, PCM powers and grounds, vacuum leaks, air intake or exhaust restrictions, signs of internal engine trouble, moisture on ignition parts, fuel level and quality concerns, and load-related issues like bogging or towing overload. If you find a real fault here, repair it and verify the repair before moving on. Next, with the ignition off, inspect the MDS solenoid harness connectors, jumper connectors, locks, seals, terminals, tension, corrosion, water intrusion, overheating, and pushback or spread terminals. After that, check the engine and intake manifold for vacuum leaks. Then check fuel quality for water, wrong fuel type, old or contaminated fuel, low fuel and proper ethanol level. If the fuel is bad, replace the fuel and if needed, flush and clean the fuel system before verification. Now check whether the cylinder 6 injector is clogged, leaking, or flowing differently than the others. The fuel system stays under pressure, even with the engine off, so release fuel pressure before opening any fuel hose, fitting, or line. Use fuel pressure decay tester 8978A at the fuel rail. Key on, let pressure build to maximum and stabilize, and record that as the starting pressure. Actuate the cylinder 6 injector with the scan tool while watching the gauge, then record the ending pressure. Repeat the same process on several known good cylinders, always starting from the same starting pressure. After each injector actuation, start the engine to clear fuel from the cylinder so you do not risk engine damage. The diagnostic point is the comparison. If the ending pressures are about the same, keep going. If cylinder 6 stands out, a small pressure drop points you toward debris or restriction in the rail or injector, and a large drop points toward a faulty or fouled injector. Repair what is found, then verify the repair. Before moving from fuel to ignition, turn the ignition off, remove the fuel pressure decay tester and reconnect the fuel lines. Remove the ignition coil from cylinder 6, reconnect the coil connector, disconnect the cylinder 6 fuel injector connector, install a spark tester on the coil and crank the engine. You are looking for a crisp blue spark. If that spark is not there, the flow moves to the coil power and control circuit tests later. If spark is good, turn the ignition off and inspect the cylinder 6 spark plug and cylinder. Look for cracks, carbon tracking, oil fouling, coolant fouling, excess fuel, plug gap out of specification, a loose or broken electrode, and any sign of oil or coolant in the cylinder. If those conditions are present, replace the spark plug, and if oil or coolant is in the cylinder, diagnose and repair that cause. If the plug and cylinder inspection do not explain it, perform a compression test on all cylinders and compare cylinder 6 to known good cylinders. If compression is not within specification, use a cylinder leak down test to separate valvetrain trouble from combustion chamber trouble, then repair what is found and verify. If compression is within specification, exchange the cylinder 6 spark plug with a known good cylinder, or replace the plug if access makes swapping impractical. Start the engine and watch the misfire monitor. If the misfire follows the plug, replace the plug. If the plug was replaced and the misfire is gone, the repair is complete pending verification. If the misfire is still there after the plug, spark, injector comparison and compression checks, decarbon the engine using MOPR combustion cleaner. After driving and clearing the cleaner from the engine, erase the code, test drive under the captured conditions, and watch the misfire monitor. If the misfire does not return, the valve and combustion chamber cleaning corrected the fault. If it does return, check engine oil level and condition before going deeper. Look for mechanical tolerances out of specification, oil pressure out of specification, low oil level, the wrong oil filter, dirty or deteriorated oil, contaminated oil, wrong viscosity, or aerated oil. Repair any oiling or mechanical issue that is found. If the misfire happened when engine speed exceeded 5,000 RPM and VVL operation is suspect, check that system. A rocker arm stuck in low lift mode can cause this type of high RPM misfire and may not set a VVL code. Before inspecting rocker arms, make sure the VVL solenoid O-rings are not missing or damaged and that the solenoid is not leaking when off. If the VVL system checks out, visually inspect the camshaft lobes, rocker arms, and springs for excessive wear or broken parts. Repair the issue found, then verify. For the no-spark path, keep safety in mind around a running or cranking engine. Stay out of line with the fan, keep hands away from pulleys, belts, and the fan, and avoid loose clothing. Start at the ignition coil feed. With the ignition off, disconnect the ignition coil connector. Turn the ignition on, actuate the ASD relay with the scan tool, and use a 12-volt test light connected to ground to probe the ASD relay, F342, output circuit at the coil connector. If the light does not illuminate brightly, stop scan tool actuations and repair the open or short to ground between the PDC and the ignition coil connector, then verify. If the feed is good, use a 12-volt test light connected to a 12-volt source and back probe the coil control circuit at the ignition coil connector. Crank the engine for 5 seconds. If the light blinks brightly while cranking, the control circuit is being driven and the ignition coil is the supported repair. If the light stays on constantly, check the coil control circuit for a short to ground. Turn the ignition off. Disconnect PCMC2 and install the GPEC Diagnostic Adapter 10436 on the engine harness side. Do not probe the PCM harness connectors directly because that can damage the terminals and create poor terminal-to-pin contact. Check continuity between ground and the coil control circuit at the coil connector. If there is continuity, repair the short to ground and verify. If the test light stays off constantly during the control test, measure resistance of the coil control circuit between the coil connector and the GPEC adapter. If resistance is not below 3.0 ohms, repair the open or high resistance and verify. If it is below 3.0 ohms, continue to the final connection checks. If the earlier checks have not isolated the cause, disconnect the PCM connectors, related inline connectors if equipped, and related component connectors. Inspect connector installation, locks, corrosion, water intrusion, weather seals, bent terminals, Overheating from poor connection, push back terminals, spread terminals, and terminal tension. Repair any connection issue you find. Then reconnect the PCM, inline, and component connectors, making sure everything is fully seated and locked. Erase the code, operate or test drive the truck under the same conditions that set the code, and read codes again. If P0306 returns after those checks, the supported final step is to replace and program the PCM. If it does not return, the wiring or poor connection issue has been repaired. The takeaway is simple. Prove cylinder 6 is active, separate fuel, spark, mechanical, oiling, and control circuit causes in order, and verify the repair after each confirmed fix. For more diagnostic training, visit stepdiagnostics.com.